All right, hi guys. Today I'm going to teach you a little bit about geologic time. Some of the, rules or laws that go into place when you're trying to find the ages of rocks. So, like, just for example, if you look at this picture, there's going to be a way at the end of this video that you can tell where the oldest rock and where the youngest rock is. So, as you watch this video, I would encourage you to take notes. That means you can pause the video at any point, write things down. But I'm just going to cover some of the stuff that wasn't covered in your Apex book from yesterday. So when we get started here, yesterday you should have looked at relative age versus absolute age, or in your Apex it may have been called relative dating versus absolute dating. So relative age is just approximate age. So like for example, I am, older than Miss Trevisano, but I'm younger than Mr. Vaughn. That's my relative age. So if you saw all of us, you would get an idea of about how old I was. Absolute age is giving the exact age. So I am 31 years old is absolute age. So that's the difference between the two. So when we're looking at the ages of rocks, we're usually using the relative age. We're giving about how old they are instead of saying exact because we're not really sure. So what we're going to do is we are going to look at how we actually find the ages of rocks. So we have some kind of like rules or things you have to keep in mind when you're trying to find out these ages. So in your notes, I would title it with this, what you see on your screen, and then the things we talk about in the next couple slides, I would add below. So the first thing that you will see is a big fancy word, and it is called Uniformitarianism. And what I really want you to pay attention to is actually going to be, within this word, you're going to see the word uniform. So if everybody is wearing a uniform, they all look the same. And that's what I want you to think about when you see this word, is the word same. All this word means is that scientists or geologists, when they're looking at rocks and land now, they assume that the same things that are shaping the land now that we know about, earthquakes, volcanoes, the way the plates move, is what used to happen a long time ago when people weren't around. So I think the big part right here is the present is the key to the past. So what's happening now is also what used to happen a long time ago when we weren't around. And that's just simply called uniformitarianism. Now, this is called the law of superposition. So what this means is when you have rock layers that are nice and horizontal like this, the oldest is always going to be at the bottom and the youngest is going to be at the top. So if you think of this as like a sandwich, for example, when you're making a sandwich, you would first put down a piece of bread, then you would put a piece of turkey, then you would put your cheese, then you would put another piece of bread. So you don't just put the turkey first. So we know like the first thing that was put down was this piece of bread or this rock layer because things couldn't be on top of it if it wasn't put here first. So that's just simply the law of superposition. So when you have horizontal layers like you see right here, layers stacked on top of each other, the oldest is at the bottom and the youngest is going to be at the top. So that one's pretty simple, but I do think it's important that you have it in your notes that oldest is always at the bottom and youngest is always at the top. There are two different vocab words that I would like you to add, and it's called extrusion and intrusion. With this, I want you to think of exterior and interior. So for extrusion, if you think exterior of the house, that's going to be the things on the outside. So an extrusion is simply the lava that hardens on the surface. So a volcano erupts, you have the lava that flows on the surface and it hardens. That's going to be called extrusion. Intrusion, I want you to think interior of the house. It's inside. So this is whenever the magma hardens underneath the surface. So where we can't see it, it's in the rock layers. One thing that you have to understand is whenever you have something like you see right here, this area is always younger than all of these layers behind it. So these layers had to have been there, and then all of a sudden this came up. So this would be the youngest layer. And that's something we'll get more practice with, but I think it's really important that you have in your notes, and intrusion is always younger than the rock layers around and beneath it. Fault is something you should have included in your notes. We've talked about it with earthquakes. It's just simply that break in the Earth's crust. The reason I'm adding it again today is because I want you to think of it as if you cut your sandwich. So you've made your sandwich nice. You have your bread, your turkey, your lettuce, tomato, bread, whatever it might be. You make your entire sandwich and then you cut it. So what that means is when we're looking at this situation right here, all of these layers, C and B and A and even D, all had to be there before you could actually cut it. So this E that you see, this straight line, because that's going to be your fault, that's what shifted all of these layers. So again, all of the ones here, A, B, C, and D, all had to be there before you could cut it. And again, you'll get more practice with it, but just trying to give you a preview of it now. So here's a picture, and what I want you to think about is what layer is the oldest and what is the youngest when you look at this. So the way you kind of have to look at this is think of it as if you're looking at the side of something. Okay, things are stacked on each other. You kind of have to put it in two different perspectives. So you have stuff that's stacked on top of each other this way, but then they overlap each other in front ways too. So it's just kind of a visual thing you have to keep looking at. So when we look at this, we're going to say what layer was the first one that had to be laid down. So if you think A is the oldest layer, you are correct. So this was the very first layer that had to be there. The next layer is going to be B. This layer had to be there next. Then C. Then D. Okay, if you see D goes over A, B, and C. Okay, but it's not over E, so that means that one's going to be the next youngest. And then finally, E is your youngest overall. If you look, it overlaps everything, it's on top of everything. It means it's the last thing that had to have happened, so it's the youngest. The last word that might be new to you is called an unconformity. And what that is if you look over here in picture one, is you have all of these layers were laid down nicely. So over time, sediment has been layered down. It's nice and neat. We know that the plates shift and the land moves. So over time, let's just say it began to fold. Okay, so I had this bend in it. Then let's say over time, because it was constantly being eroded away, a bunch of the layers disappeared. Okay, so we're just going to get rid of that first part. Eventually, over time, a new layer might be put down. So what that means as far as unconformity is actually right in this area, if you look at this, over here you have this yellow area is pretty old when we look at all of these, because remember it goes oldest all the way to youngest. So yellow is pretty old. When we go over here, that old yellow layer is touching a new layer. So right here, there's going to be a big gap as far as age is concerned. They're going to find really old things here and maybe newer things here because there was areas that were eroded away. That's just called an unconformity. It's almost like you're unsure, okay, an area that's missing. All right, the next couple slides, I'm just going to give you some example ones. We will do a bunch together. So if you're feeling a little flustered because you're confused, please don't worry. Just do your best on these and we'll get more practice together and we'll go from there. So what I did here is I picked 4 different shapes or different colors, the way you want to look at them, and I laid them down. And I just want you to think, which one did I put down first? Which one did I do second? Which one did I put down third? And which one did I put down last? So I know this seems very simple or generic, but that's really what you're going to be doing in these problems. So when you're looking at this, the very first shape that I had to have put down was the blue square. So blue square was actually first. Okay, if you look, it's behind everything. So it was the first one that I had to lay there. The second one is going to be the yellow circle. The third one is the green square, or sorry, the green star. And then finally, the last thing, because it's on top of everything, is going to be the red rectangle. So now let's look at this one. I want to know which one's the oldest and which one's the youngest. Okay, the oldest is going to be the layer that's at the bottom. Remember, we think of this like a sandwich. The first thing they had to have put down was layer F. After that, it was C. After that, it was A. And the youngest layer, the newest layer, is going to be G. Okay, here's one. You can pause the video now so you can try this on your own, and then I'll give you the answer. Okay, for this one, as far as age goes, the oldest one is actually going to be B. Okay, it's at the bottom here. And then you have X, and then P, and then H. And those at one time probably were horizontal and nice and neat, but we know that the plates move and the layers bend. So that's why it's kind of folded in a different direction. But that would be oldest to youngest there. And then you would finish off with M, and your youngest or newest layer overall is T. Okay, with this one, you have three different things going on. You have them kind of stacked on top of each other, but then they overlap again. So if you want to try this one, go ahead and write it down. Okay, the oldest one is going to be A. Okay, it's the one on the bottom of everything, and then stacked on top of that is going to be C. And the youngest one, because it overlaps everything, is B. So A was laid down, C was laid down on top of it, and then B was actually magma that was pushed up and just kept going all the way through. So it's the newest layer, it's the youngest. All right, go ahead and look at this one and give it a try. Okay, for this one, you could have had two possible answers. So you could have said your oldest is S, then L, then X, then B, and then T, because you could say T is currently in the process. You could have also done S, then L, then X, then you could have said T, and finally B. So either one of those would be acceptable, because we're not really sure if this is still in the process of intruding upward, or if it did and then all of a sudden B was laid down. So that's kind of up to you. All right, so on the next two slides, there's ones that are a little more challenging. It's just kind of to see if you can do it. I'm not going to give you the answers till tomorrow, so if you want to pause the video, try them in your notes, and then I'll give you the actual answer when I return. So here's the first one. So you can go ahead and either screenshot this or pause the video and try it. And the second one is going to be here. Okay, so I just created these pictures, so I just want you to tell me which one did I do first and which one did I do last. And you can try that on both pictures, and then we will practice more tomorrow.